here we're going to create a local variable. Now this variable, it's not going to appear when we save here in this area where the binding variables are. It won't show up here in structure where you will not be able to bind to it. It's a variable that basically only exists in the scope of this program, and the only way you can see it is we'll make a comment. So this is how you create comments. Comments take up an entire line once you type that apostrophe. So this is a good thing also to have separate lines for every variable you declare, because you also get to add a comment at the end of that variable declaration about your variable. So A is going to be the sum of AV1 plus A and AV2. B will be the remainder of the sum above, and AV will be a local variable that will store the cube of that now with some arithmetic and assignment operators. So the first thing the first operator that we will always use, and perhaps one of the most confusing operators, is the equal sign operator, because the equal sign operator can be used for two completely different functions depending in which context it's being used. So the first context that a equal sign operator can be used is for assigning values into variables. So here we use this equal sign operator to assign into the local variable A that we declared on line 10 the value of AV1 plus AV2. Then in B we will store the value of A, were divided by the value currently being held in AV3. The remainder of that division will be stored in B by using the operator MOD. So here we see two arithmetic operators being used and the assignment equal sign operator being used twice. And then lastly we'll assign a value, the value that we predicted in our comments, to C, and C will have B to the cube, to the power, the third power of B, basically. So this should now work. So provided we've done what we had to do here and provided the necessary values to these points that we're already using. Okay, so analog value 1 has a value of 1. We can see that here. AV2 has a value of 5. We can see that as well. Oh, AV3 is going to be a problem. And here, let's see why I'm saying that. AV4 we also see that has a value of 0. So in theory, if we pass A to AV4, we should have 6 now. And here's the first issue we're going to have. So as you can see, it did not compile. We have a compiler error. There's a problem with our syntax. So we'll do quick analysis here of this stack trace for the error that we generated. So in line 17, we cannot set this variable. Make sure it's not an input or a function variable. So indeed, it is an input. So we're gonna have to fix that. So the fastest and easiest way to resolve that problem is to turn it into an output. And now we saved, but yet we still don't have the expected value here. We do not have a 6, which should be the value stored in A. So now the error is not so obvious. So this is a neat little feature that this code editing tool provides when used for StructureWare native script. When used for B3 script, it will not work because there's a number of features in the language as well as in the code editing tool that StructureWare offers for their flagship products, the StructureWare, the EcoStruxure group of products that are not available for other products such as the B3 controllers. We're going to use this feature here since we're writing this script in an enterprise server in order to debug our code and see why we're not getting the expected value for AV4. And here we stepped through a line of code that gave us a try to divide a value by 0 exception. So this is a runtime error compared to the syntax error that we had earlier, which was very clear and easy to decipher where and what the problem was. In this case, the value just didn't show in AV4. The value that we expected, we wanted a 6 here, but we didn't get it, and we also did not get any kind of message or clue. So that's where having this is beneficial, and in the B3 controllers we'll have to employ more creative techniques in order to debug our problems and try to figure out this kind of runtime errors and trouble. Now that we know what the problem is, we might be able to track it, and let's see, well, the most obvious solution here would be to AV3 that is now 0, at least give it a 1. Well, let's go with a 2. Actually, let's go with a 4, because we know that the remainder of 6 divided by 4 should be 2. So that'll be an easy one to troubleshoot if we have a problem with that. So, and now the program is working as expected. AV3 is 4, and since we are assigning using this equality, equal, not equality, the equal sign operator as an assignment operator, we're passing the value of A, which was already assigned to A in this expression here, to AV4, so that value would be 6. So now we're gonna pass a different value to AV4. We're gonna pass the value of B to AV4, and as expected now, the reminder of dividing the value in A, which was 6, and the value from AV3, which was 4, the remainder of that division is going to be 2. And so when B is assigned, the value in B is assigned to AV4, AV4 now is displaying a value of 2 down here. And just to see if our if we did the exponent operator the right way, let's see. So 2 the cube of 2 would be 8. Is that correct? I believe it is. Let's see. Yes, I'm pretty sure that's absolutely correct. So what would have happened if instead of doing that, we'll comment selected. Now that's a neat little trick in order to remove code from being executed, but not removing it from the actual program. In case you screw up and you need to go back to a place where you were before you started rewriting or modifying somebody else's program, you did not delete the code that you were given initially, and you can always go back to square one. Whereas if you start deleting somebody else's code and then your code doesn't work, then you're kind of screwed, because you're not even going to have a square one to go back to. So what would have happened if we had done 3 squared b? What would that give? So that would give 9. So here, changing the placing of the values around the operand. So in an expression with operators, these are the operands, and this is the operand. I'm sorry, this is the operator, and these are the operands. So the reds are the operands, the operator is the one in the middle. So the placing of the operands across the operator mean a great deal in just about everything except for multiplication and addition. So in addition to all that, we're also going to have parentheses, and in the PDF documents that will be provided, you'll see how exactly how parentheses is used for typical arithmetic and algebra. That's exactly how parentheses is used here. And in fact, parentheses can be used to change the order of arithmetic or mathematical operations to be whatever you want it to be. Parentheses basically overrides anything else. Anything in parentheses always takes prime and most precedence in any kind of expression. So we're also going to have the typical Boolean comparison operators, and for that I think I'll just use this Python shell, and we'll see how that works. So 4 is greater than 5, false. 5 is greater than 4, that's true, as you would expect. 4 is greater than or equal to 4.14. No, it's not. 3 is greater than or equal to 3. Yes, it is. 3 equal, it's greater than 2. Yes, it is. 3 or equal than 1. So these are your comparison operators.